Good afternoon, everyone. My name is Mohsinul Kabir. I'm a PhD student at the University of Manchester at the National Center for Text Mining Group. I'm also affiliated with Ellis Manchester. So today I'll be talking about evaluation of cross-cultural reasoning in the large language models. Um, so when it comes to cross-cultural reasoning, uh, this is not like any other benchmarking. Like when we talk about uh, benchmarks on mathematical reasoning, code correctness, or let's say factuality, those are domains that are culturally invariant. Those are depends on logic that remains same across all the cultures, across all the languages, mostly. But when it comes to domains like machine translation, figurative language like irony or sarcasm, or let's say mental health, these are very, very culture dependent and very context specific as well. There is no like right or wrong answer when it comes to benchmarking this because it varies greatly from one culture to another. So let's say for sarcasm, so if you come to UK, the British sarcasm is quite bold and rude. But if you that if the same language is used in countries in South Asia, it might be quite offensive in many of the cases. So it is very important that when we do benchmarking and we deploy AI systems or LLMs in those particular domains, uh, it is important that the LLM should understand the context that which people they're working on and which context they're working in. Um, the problem with the existing cultural benchmarks are mostly the cultural benchmarks out there are mostly QA based, question answering based. Those uh, those benchmarks that claim to evaluate or benchmark the cultural competence of large language models are mostly uh, benchmarking the cultural knowledge, not the reasoning, because LLMs can pick the right answer based on what it saw during the pre-training phase. But understanding what are the important cultural aspects and how to adapt from one culture to another culture is a completely different game. And it is important that we utilize the uh, theories of social science and anthropology in benchmarking this cultural reasoning or cross-cultural adaptability, because those if we claim that we have evaluated a culture as a whole, uh, it has been criticized a lot in the past literature. It is difficult to claim I have evaluated culture as a whole. We can evaluate particular aspects of culture, but not culture as a whole. So with those theories of social science and anthropology can give us frameworks that um, we can use to evaluate particular factors of cultural paradigm of a particular community. And also, this culture specific annotation is very expensive. You have to manage people from the native culture. You have to spend a lot of money, time to annotate those, because uh, you cannot use LLMs for as annotators. It will generate circular data, like data annotated by LLM, evaluated by LLM, and specifically in cultural domain, this is very risky because, um, as I said, there is no right or wrong answer in these domains. It remains very subjective, and the subjectivity in this particular domain is the diversity, is the rich annotation data that we need to evaluate these cultural aspects. So we have attempted to address these limitations and come up with a benchmark that is called XCR bench, or cross-cultural benchmark, that that creates real-world scenarios from cultural facts. We have designed tasks in a way that invoke the reasoning traits of LLMs, and we have also utilized um, uh, two theories from social science. It's Newmark CSI typology and Hall's cultural triad, which I'll be talking on the next few slides. So Newmark's CSI framework is basically, so CSI stands for culture specific items. So if you have, so this is a framework mostly working in machine translation domain. So if you have a sentence, it basically figures out which particular span or which particular keywords are culturally salient or culturally crucial. Because when we try to adapt from one culture to another in machine translation, we do not need to adapt the whole sentence. You can do part of the sentence literal translation, and only a few only a few keywords need to be adapted, like let's say festivals, the tradition, the stereotypes, which are not invariant, which varies from culture to culture. So Newmark's CSI framework actually gives you um, that explains what is the cultural element in a particular sentence. And a whole strand of culture, also known as the iceberg model of culture, um, this basically uh, divides the whole culture into three different layers. So the first layer is visible layer, that are often the observable practices like the festivals, the artifacts, the rituals that we see that differ greatly from one culture to another. And at the other extreme, we have the invisible layer, which are basically habits um, um, that are generated by the community of a culture after, let's say, 1,000 of years. Let's say one particular culture is individualistic, another culture is capitalistic or socialistic. So these are the caveats that the whole strand of culture gives you. So the CSI framework at the one end gives you what is the cultural element, and Hall's level gives you how deeply the cultural element is embedded inside the culture. So we have annotated both of these, or we have incorporated both of these frameworks into our corpus. This is how we built our corpus. We sorry, um, sorry, yeah. So yeah, so um, so at the first phase of our this is how we built our corpus. So at the first phase, we extracted cultural knowledge or cultural facts from two well-known cultural bank, which are Candle and Cultural Atlas, and we also used Wikipedia to extract the explanation of those cultural facts. So let's say we have a very general statement from Candle or Cultural Atlas. Let's say a wedding ring is a finger ring that a woman or a man wears after marriage. So what is the CSI here? The CSI, or the culture specific item that varies from one culture to another culture, is the wedding ring, because For example, in Bengali, in Bangladesh, a nose pin is more popular than a wedding ring. So we extracted this CSI and the cultural context, and then we give this CSI and cultural context to three different LLMs: GPT-4o, Claude 3.7, Sonnet, and DeepSeek R1. These are the models that were uh, that were SOTA model at the time when we built or constructed the corpus. So we prompted the LLMs, given this CSI and cultural context, asked for real life grounded scenarios. So, and then we did human evaluation based on cultural naturalness and fluency. And that's how we produced the real life scenarios based on the CSIs. And finally, we annotated the CSI category and whole civil annotation using the framework we used from Newmark and Hall-Salzberg model. So you might ask why a wedding ring is semi-visible as shown in this particular example, because a wedding ring you can see, but the underlying meaning of the wedding ring, the commitment that the wearer possess to his or her partner, is semi-visible. So these are concrete guideline extracted from the book of Edward Hall, that the annotators were provided with, and they provided annotation based on those particular framework. So yeah, so and another thing is we also annotated culturally adaptable sentences. For example, the sentence here is at the end of the second phase here. You can see she never takes off her wedding ring, blah blah blah. So we also translated it or culturally adapted it into Arabic, Chinese, and Bengali. So, but we did two variations of Bengali because, as you might know, Bengali is talked or spoken in Bangladesh and part of India as well. And those are two distinct cultures that varies a lot because the religion is different, the lifestyle is different. So we had four distinct cultures. We annotated the adaptation, so that gave us around more than 4,000 parallel sentences and around 1,000 CSIs. With this, we tried to answer, with this corpus, we tried to answer this single research question: do LLMs reason about culture, or do they only match familiar cultural patterns? Because when you ask an LLM a particular question in a QA style format, it tries to steer around its knowledge and gives you an answer. But when we are talking about reasoning, it has to hit the cognitive layer to recognize which particular element is culturally salient. It has to infer or determine what cultural expression fits a particular context, and it has to adapt, like what is the communicative function that has to be maintained or preserved when we move from one culture to the other. So this is, as I said, a complete different game than a QA style closed benchmarking. So to do this recognizing, inferring, and adaptation, we designed these three tasks using our corpus that I discussed before. We had to the LLMs were prompted to identify. So the CSI annotation were removed, and it was asked which particular keywords or which particular span in the sentence is mostly responsible for cross-cultural adaptation. Then we did a mask filling type task. It's called prediction, CSI prediction. So we removed the CSI from the sentence, then masked it using a simple um, mask layer, um, mask keyword, and then we finally do an adaptation. Like we give the same, we gave the full sentence and asked the LLM what will be an culturally equivalent sentence in, let's say, Chinese, Arabic, or Bengali. So we also designed task-specific evaluation metrics for the CSI identification and CSI prediction task. We designed uh, a hard evaluation metric and a soft evaluation metric. The hard evaluation metric is basically exact string matching that penalize even the correct responses because it directly tries to match the strings between the CSI spans. And the soft metrics are mostly similarity-based metrics like Levenstein or cosine. The adaptation task, we didn't use any hard metrics. Uh, we tried to go for more lenient approaches for this particular task because after a few cycles, we understood that the cultural equivalence might be semantically similar but correct, uh, but not lexically identical. So we used language-specific BERT for from each of the languages, and uh, we just measured the BERT score on the CSI span on the full sentence span. The result prediction was far easier than identification because um, we guessed, or you can say it's a presumption, though you didn't say it in the paper, that like mask filling is quite might be um, quite easier for LLMs because mostly all of the LLMs are trained using the language modeling, which are basically predicting the next token. So it can exploit the pre-training exposure, but it was very difficult for the LLMs where it could only like cross like 50% for the CSI identification task because it struggled to decide like what part of the sentence or the phrases matters culturally, and that changes from culture to culture. So this is what exactly the closed style QA benchmarks fail to understand or fail to capture. Cultural depth. So as I said, we used Edward Hall's triad of culture. So for each of the sentence, we tried to um, annotate the visible, whether it's a visible, semi-visible, or invisible cultural element. And we saw that there was a clear decline from visible to invisible uh, cultural elements. So these are not real results. These are over average of the 8 models that we used, but the results here are statistically significant with p-values less than 0.005. So for the prediction task, it becomes the decline that you can see become very steep. The values, the beliefs, the orientations, um, these are the most difficult categories for LLMs to identify and adapt as well. Which particular values, beliefs, or orientation? This has been reported in our paper, but for the like space limitation, we couldn't. I couldn't list it in here. So We did another interesting experiment. For the adaptation, we did intralingual and interlingual adaptation. So, in intralingual, the LLMs had to adapt from English to English. So it kind of had to uh, explain what would be a um, culturally equivalent sentence for a particular scenario. And for interlingual, it just directly had to um, uh, translate from one language to the other. It had to in native language, and we saw that um, LLMs actually struggle to kind of explain in intralingual setting. So this English only adaptation collapses into stereotypes and transliterations as well. And you can see the gains from intralingual to interlingual, and the gains are largest for Arabic Chinese, but the gains are not that much in Bengali. As you might know, the Bengali is a low resource or resource scarce language. So the LLMs do not have the expertise in Bengali as much as it has in Arabic and Chinese. So even in Bengali, um, the performance drop for the low resource languages is clearly shown in here. Bias. So uh, this is like another interesting finding from our paper. For the Bengali, as I said earlier, that there are Bengali speakers in Bangladesh and India, and most speakers, like 60% around 60% of the speakers live in Bangladesh, and around 40% live in India. And these are distinct cultures because mostly of the religion. So the most most of the people in Bangladesh are Muslim. They follow Islam as a religion, and the people of India, they follow Hinduism. So, when it comes to population, Bangladesh has the uh, dominative population because the majority of the people and the majority of the people following Islam as well. But when it comes to LLM predicting or adapting from English to Bengali, it mostly adapt to the dialect or the cultural aspects of the West Bengal, which is a part of India. So, though Bangladesh is the demographic majority, the preference of LLMs actually is more inclined towards the cultural aspects of India. So it encodes a type of, you can say, uh, linguistic bias, cultural bias towards. Probably it might be the case, though we couldn't actually test it, that most of the Bengali data might be constituted of the literature from the West Bengal. That seems to be the most plausible explanation to us. So when it comes to kinship, the festivals, the lexical marker, most of the um, most of the linguistic uh, markers were inclined towards the West Bengal, which is part of like the India as a country. Finally, we tried to see whether the prompt sensitivity has anything to do with the reasoning. So we tried, though there is an ablation study, we didn't run this on the whole data set. I think it was done on 10% of the data. So we did expert prompting, chain of thought, reasoning, and then few shot with 3 examples. And we didn't find any statistically significant advantage of any of the prompting technique. So that might lead us towards the conclusion that the reasoning gaps specifically the cultural reasoning gaps, might not be resolved by only prompt engineering. But then again, if we could run the whole uh, experiment on the whole data set with more cultures incorporated, that might give us a more plausible explanation towards this. So I'm almost at the end of my presentation. So what should be the takeaway? As I said, QA style cultural benchmarks are inadequate, not only because it doesn't steers the reasoning, but also the richness of analysis that you get from from a corpus built on strong theoretical frameworks. You cannot get this from just QA style benchmarks. So this uh, theoretical frameworks, specifically when it comes to benchmarks on cross culture or social science, these are very important that we study them and we incorporate them into these benchmarks. And this interesting finding of like regional performance preference, this bias, these are apparent in when we apply a framework, a strong theoretical framework in building our corpus and in our tasks as well. So this is just the starting of what we started as a cultural competence evaluation, but like we should ask how we can define when we claim that the model is cultural competence. So when we claim that a model is culturally competent, we need to think how we can design more interesting benchmark that goes beyond factuality, safety, and translation quality. So thanks everyone. So this is all from myself. If you have any questions, so this is there's a preprint from this paper that I just discussed. So if you're interested, you can go through the paper, and if you have any question, I'm happy to answer them. Thanks.